Number 11, if arc YZ is the diameter, why does he's the diameter? Well, if he's the diameter, we know, okay, or it just says, it actually says line segment YZ is the diameter. Okay, if YZ is the diameter, that means it cuts through the dead center, meaning this part is 180 and the whole part up there will be 180. Now, it also tells me, though, that this inscribed angle right here to there is 90 degrees. So I know I now have 90. With it telling me that's the diameter, I can figure out, oh, that inscribed angle has to be 90. What else does it give me? It gives me arc XZ is 120. Giving me that, well, if he's 120, here's the inscribed angle to 120. He's got to be 60. And then the triangle makes that 30. And of course, then that's got to be 60 because it's double whatever the inscribed angle is. What does it ask me? X to Z to Y. 30 degrees is my answer for number 11. Number 12. Ooh, look at him with all these X's. Looks a little complicated. We got BAD is 5X. Okay, great. Granted, that means BD is 10X, but I don't think we're going to need that. Let's see. Arc AC, arc AC is 7X. So this is 7X. Okay. DCB, D to C to B. Okay, this is 65, right? That's an inscribed angle. The arc it creates over here is going to be double that 65, so it's going to be 130. Now, it also means this 5X you and I had a minute ago is going to be 65. That means that 5X is going to be 65. If we want to know what X is, which I sort of do, and I don't know whether I'm going to need it or not, X is 13. Okay, now that is interesting because this said this was 7X. So it's 7 times 13. So let's figure out what that is. What's 7 times 13? That's 91 degrees. So this guy is 91 degrees. All right. Don't know if that's going to help me or not. Let's now see what we have. We have what is A to B to C? A over to B, back to C. Oh, it's the inscribed angle. So it's half of that 91. So it's simply half of 91, which is what? 45 and a half degrees. It's an ugly. It's got a little fractional part. So the answer is 45 and a half or 45.5 degrees for number 12.